Okay, we're getting into Unit 3 now, and Lesson 1. Unit 3 is all about linear equations. And then Lesson 1, we're going to be able to rearrange the equations of a linear equation from one form to the other, and then be able to relate the key features of a linear equation in the different forms. Okay, so linear equations or expressions, what do they have in common? Well, they're lines, a straight line, right? One straight line. There's no curves in them, there's no twists. It's a single straight line, okay? And then one thing that you can derive from a straight line is their rate of change, their slope, right? And we figure that out by how much rise there is over its run, okay? It's rise over run. Rise divided by the run. It's how much change in y, okay? The change, so this delta sign here, this is the Greek letter delta. This is the symbol that they use throughout mathematics and science for the change in. So the delta is change in. So the change in y, right, for the change in x, or the change in your vertical for the change in your horizontal, okay? So your change in your, or the change in your domain, or your range for the change in your domain, okay? If you're just talking about a certain part of a line, okay? So your x value and your y value. All right, so for this, and these can be positive or negative, right? So if my change in x for a change in y is positive, I'm going to have an upward slope like this. If my change in y for my change in x is negative, I'm going to have a downward slope that would look like that. Okay, so here's a little show what that would look like. So here's a point right here that intersects at a good spot. This would be my 0. As my x intersects x at 0, and then my y value would be -2. Okay, and then my here's a good spot where it intercepts. It's easy to count, and this is this here is like 4 and 1. Okay, well you see here for every change, so my change is 1, 2, 3. 1, 2, 3. So this is 3 blocks. 1, 2. That is a 3-block change. Okay, so it goes from -3. So the absolute value is -3 to 1. That's delta of 3, right? So my change in y, was 3. Okay, and then my change in x from this spot to this spot is 1, 2, 3, 4, right? So that's 3 over 4. So for every change in 3 up, it goes 4 over, right? So my slope is 3 over 4, positive. It's positive 3/4. Okay, and I know it's positive because it's going up, right? And I'll show you how to do the math with that later, right? And slope is indicated by the letter M for slope. M is for slope. So in this case, slope is M, and it's the change in y over the change in x, or your slope is also can say it's your change in y equals your initial y, or your final y, minus your initial y, and your change in x is your final x minus your initial x, right? And usually it's left to right, but your final can be right to left as long as it's consistent. The math will work out, okay? And the y-intercept is where the line crosses the y-intercept, or the y-axis, excuse me, where this function y, right, we'll call this function f sub x, of course. F sub x is y, right? Where this function y enters, the function crosses the y-axis. So here it's just going to be -2, right? So when f is 0, right, y equals -2. Okay, so that is our y-intercept. Okay, so when we put it in our slope-intercept form, right? Slope-intercept form. Our slope-intercept form uses our slope and our y-intercept. Okay, so saying that our slope, or y, or our function equals our slope, right? Y equals m, and then our x value, x, plus our y-intercept, b. And I want you to take a look at this. This is kind of an easier way to think about it, right? Our slope is a change in y over a change in x, right? So this is like if you think about units, like our slope is a change in y over a change in x, right? This would be a y minus a y would be equal, a y minus a y would equal a y, right? And a change in an x would be a y, an x minus an x would equal an x, right? Well, in order to make unit analysis make sense, it's a y is going to be equal to a y minus an x plus, and our y-intercept is going to be a y value plus a y, right? Because our x is 0 at the y-intercept, okay? So in order for this to make sense, this has to be an x plus a y value, right? Because this is all going to equal y, right? Y equals mx plus b. Y equals mx plus b. This is our slope. This is our slope, which is m, right? So in order for this to make sense, our change in x has to be on the bottom, because it's going to be a y equals a y plus a y. So that should make sense, okay? So that helps you remember that it's change in y over the change in x. The x's would have to cancel out, so the x's has to be on the bottom for slope, okay? Point slope form, oh, by the way, it's all written right here, y equals mx plus b, right? Anyway, our point slope form is saying, hey, if I have my y value minus any point's y value on the line is going to be equal to my slope times an x value, my x, minus any x that I have on the line, okay? And we'll show you how we can use that a little later. Okay, and then standard form, like you know, is going to be an x value, an a for a coefficient of my x, plus or minus my b coefficient for my variable y, right, equals a constant, equals my constant. That constant is more or less going to be my y-intercept. Okay, so that is that, and that is pretty much all we're going to get into for this section. All right, we're going to get more into all this stuff a little bit later. Well, I guess we can talk a little bit more about going back and forth from this one. So say we have this equation, and we want to convert this equation into the point slope form. Like this is the equation of this line here, right? We've already determined that the slope of this is 3/4. Okay, so I want to convert this into point slope form. All I got to do here is solve for y. Okay, so in order to solve for y, I'm going to isolate my y variable. All right, so I'm going to get the y by itself. All right, so it's going to be, I'm going to subtract 3x from both sides. All right, so it's going to be negative 4y equals negative 3x plus 8. Okay, I got rid of the 3x from that side. All right, now I'm going to divide both sides by the coefficient of my y variable, which is going to be negative 4. I'm going to divide this by negative 4, and I'm going to divide all of this by negative 4. Okay, so that's going to be y equals negative 3 divided by negative 4x minus 8 over 4, right? Or plus negative 8 over 4, which is going to be equal to 3/4 x minus 2, right? And you'll see from here that 3/4 is my slope, like I calculated up here, and my y-intercept is negative 2. Okay, so that's how you can kind of see all that here now. Okay, and then go into my point slope form. I have my slope, and I'm just going to pull out any point on here and generate a point slope form. So I have this point, I have that. We're going to use this 4, 1 here. Okay, so I'm going to say, I'm going to set up my parentheses equals my slope, my other parentheses, I have my y and my x, right? Just like that. And then I'm going to go minus and a minus. And then I'm going to go ahead and pull my x value from up here. All right, my x value from up here is going to be this, 4. And then my y value is going to be 1. Okay? And that'll set up that'll work out for my point slope form. So if I were to rearrange this and solve for y, I would get this equation right here. Okay, so that's that. Hopefully that makes sense. And well, I guess we can show you that too. All right, so this is going to be, I'll do this right here. All right, so we'll do that. All right, so I'm going to clear the parentheses from here. Y minus 1 equals 3x over 4 minus 3 times 3/4 times x is going to be minus 3. Okay, so now I'm going to go ahead and subtract 1 from both sides. It's going to be 1, or add 1 to both sides. 1 equals 3x over 4 minus 2. And there you go, you have it, y equals 3/4 x minus 2, which is what we had before. Okay, that was pretty straightforward. So I hope that helps and makes sense. And I'll go ahead and post this now.